Hello friends, welcome back to our YouTube channel. If you like this video, please like, share and subscribe. I'll share our videos commanded by our experts, so let's begin.
If you like, please like, share and subscribe. So let's begin our today's topic. Let's begin.
Passive AI copilots require a human to prompt every line of code. This one-to-one manual dependency limits the speed at which an enterprise can scale its software. To increase velocity, development is moving away from synchronous, line-by-line coding and toward asynchronous, task-driven architecture, from establishing local command line rules, deploying to the Antigravity Cloud Hub, and implementing enterprise-wide governance protocols. This local command line before bridging to remote infrastructure. Skipping straight to cloud deployment can mask underlying system mechanics. A secure architecture demands a firm, localized technical foundation. The target state is a system capable of building and testing software autonomously while maintaining the security of enterprise data. Mastering this foundational pipeline is the difference between a secure, scalable enterprise architecture and a disjointed string of AI scripts. The Gemini CLI serves as the primary interface for delegating work. It natively scans and indexes local file directories, constructing a map of the existing codebase. Anchoring itself to a Gemini.md file, it projects specific architectural project rules across the indexed map. Using this ingested context, the CLI can rewrite broad multi-file codebase components to fit the mandated standards. It then formulates and executes test scripts against these newly generated components within the local environment. While standard IDE extensions predict the next line of syntax, this CLI refactors the larger multi-file structure and verifies the logic through automated testing. Grounding AI agents in local architectural standards via Gemini.md helps prevent logic errors and ensures compliance before any code reaches the cloud. Once local standards are established, operations move to Google Antigravity, a cloud-based application for task-oriented orchestration. This interface is split into two halves. The left is the editor view, designed for hands-on, synchronous coding between the developer and an agent. The right is the manager surface, where developers queue asynchronous tasks, routing them to independent processing nodes. The editor view requires active, continuous developer input. The manager's surface executes a fire-and-forget model, where tasks resolve autonomously in the background. Developers use this layout to refine logic manually in the editor view, then transition it to the manager surface to scale execution across the repository. Antigravity's dual-pane structure addresses the cognitive load of managing multiple autonomous workflows by separating local ideation from mass execution. To connect these cloud workflows to external systems, engineers use the Agent Development Kit, or ADK, an open-source framework. It supports Python and Go, Java, and TypeScript, allowing engineers to write agents in common enterprise languages. Traditionally, connecting internal code to third-party platforms required the manual creation and maintenance of rigid API bridges, creating significant development overhead. This network graph illustrates the agent-to-agent protocol. It routes data dynamically between agents, bypassing the need for a central API gateway.
Through A2A, Google agents negotiate task handoffs with external platforms like Salesforce or ServiceNow. Removing the manual bridging between these systems reduces the hours required to maintain custom-coded connectors. Scaling an autonomous architecture relies on this native inter-agent communication, which simplifies how data moves across the enterprise. Executing these automated workflows requires secure environments. The Managed Agents API addresses this by spinning up remote, Google-hosted sandboxes. A single API call provisions this infrastructure, offloading all server management and scaling. Inside these sandboxes operates CodeMender, a security agent developed by Google DeepMind. CodeMender scans for vulnerabilities, tests patches against the system, and applies code-level fixes autonomously across dependent enterprise applications. To prevent these agents from overreaching, the platform enforces agent identity, applying the principle of least privilege specifically to non-human IDs. Surrounding this is the Agent Gateway, which blocks unauthorized AI usage and prevents data leaks or injection attacks. Asynchronous autonomy is only viable in an enterprise environment if governance and security patching are also automated and strictly bound to specific identities. The process begins locally by defining architectural rules through the Gemini CLI and Gemini.md. These rules guide the system as logic moves into the Antigravity hub to be managed as asynchronous tasks. Through the ADK and A2A protocol, the system expands to external platforms like ServiceNow and Salesforce without the need for manual API bridging. Managed sandboxes, CodeMender, and the Agent Gateway wrap around this entire network, securing the architecture from external threats. This integrated pipeline automates the security and testing phases, significantly reducing the time required between a logic change and a production-ready release. Development has shifted from manual syntax generation to the orchestration of complex, high-level systems. Engineering teams that continue to use AI solely for code completion will face a significant velocity deficit compared to those using an agentic model. The ability to architect secure, autonomous workflows has become a core requirement for the modern engineer. The modern enterprise engineer's primary contribution is the design and oversight of the autonomous digital workforce.
Traditional AI coding assistants operate synchronously, answering one prompt at a time. This one-to-one interaction model bottlenecks when applied across complex enterprise workflows. Google has unified its developer tools into the Gemini Enterprise Agent Platform. This consolidation places the developer in the role of an asynchronous software architect, managing high-level task delegation rather than manual code entry. The centralized hub for managing this digital workforce is an application called Google Antigravity. The interface divides the workspace. On the left is the editor view, designed for hands-on, synchronous coding. On the right is the manager surface, where developers deploy and monitor asynchronous, multi-file workflows. By architecting a multi-agent orchestration routine from the ground up, we can trace exactly how developers deploy, route, and secure these cross-platform digital workforces. Before deploying any autonomous agents into a broad cloud workflow, they require a precise understanding of the local system context. This local foundation is established using the Gemini CLI. Unlike a passive copilot waiting for a prompt, the CLI is engineered for active work delegation. It natively reads and maps entire file directories, building a structural blueprint of the existing codebase. In this system mapping, the CLI scans the root directory, specifically extracting the Gemini.md file. This document contains the architectural standards and the specific rule set for the repository. By injecting these standards directly into the agent's context window, it gains the parameters required to execute tasks autonomously without violating local repository guidelines. Local context provides the strict rules of engagement. To execute the work at scale, we need a deployment engine that reaches beyond the local machine. Orchestration shifts to the cloud using the open-source Agent Development Kit, or ADK. The ADK operates as a code-first framework, providing native support across multiple languages, including Python, Go, Java, and TypeScript. Historically, deploying individual AI agents introduces a severe infrastructure bottleneck. Configuring, provisioning, and maintaining separate server runtimes for each agent requires heavy manual oversight. Google bypasses this completely by using the Managed Agents API to offload server management to remote environments. Instead of spinning up a server manually, an engineer sends a single API call via the ADK directly to the Google Cloud infrastructure. This request instantly provisions a custom active agent node. These agents operate within remote Google-hosted sandbox environments, guaranteeing that their execution remains isolated from the local machine. Pairing the ADK with the Managed Agents API allows the underlying infrastructure to scale precisely with the size of the digital workforce, removing DevOps overhead. With the infrastructure provisioned, the objective is to connect these individual agents into a cohesive multi-agent orchestration routine. This node graph shows our actors: a code agent, a test agent, and an enterprise agent for Salesforce or ServiceNow. Linking them usually requires writing brittle, manual API bridges. These manual connections frequently fail as endpoints update, causing significant workflow latency. Google Antigravity circumvents this through the native integration of the agent-to-agent, or A2A protocol. The A2A protocol replaces these static bridges, allowing the agents to communicate and share data structures programmatically. As soon as the code agent finishes rewriting a component, it autonomously passes the payload directly to the test agent.
Once testing clears, the A2A protocol seamlessly transfers the state and payload to the external enterprise platforms. This final downstream operation executes autonomously, entirely bypassing the need for manual API mappings. The native A2A protocol serves as the mechanism that binds isolated AI scripts into a continuous cross-platform enterprise workflow. Operating a fully autonomous workforce at this scale introduces new vectors for data leaks and system vulnerabilities. The security layer relies on agent identity. Assigning non-human IDs to each node enforces the principle of least privilege. Surrounding this is the Agent Gateway, a perimeter defense designed to block shadow AI and intercept prompt injection attacks. For active enforcement within the code itself, the platform utilizes CodeMender, an integrated security agent developed by Google DeepMind. Rather than interrupting the sequence, CodeMender operates continuously alongside the active workflow. It autonomously scans for vulnerabilities, tests patches in the remote sandbox, and applies fixes in real time. By enforcing governance at the identity level, establishing a perimeter gateway, and integrating active code repair, engineers secure the orchestration routine against enterprise threats. Looking at this complete architectural blueprint, the orchestration routine forms a single cohesive structure. The foundation begins on the local machine, where the Gemini CLI extracts the repository standards from the gemini.md file. That local context is pushed to the cloud using the ADT deployment engine, while the A2A protocol handles internal and external routing between the agents. Within the Gemini Enterprise Agent Platform, software engineers focus on directing a governed, asynchronous workforce rather than writing granular code functions. Look at your current CI/CD pipelines. Locate the manual, synchronous bottlenecks that require continuous human oversight, and consider how a task-driven, autonomous architecture could replace them.